Hey guys, and welcome back. This is your very last lesson of Unit 1. I know you guys are probably really excited to get to the end. So we are going to finish up with periodic trends. We've already talked about the periodic table. We know how it's arranged. We know that elements in the same group have similar chemical characteristics. We know how to identify energy levels based on the period that it's in, and of course we know how to do electron configuration. So now we're just going to talk a little bit more about some of the information that we can get from the periodic table regarding the elements and the trends that we see in the table itself. And that is going to help round us out for Unit 1. So just to review, chemical properties are characteristics or behaviors of a substance that may be observed when it undergoes a chemical change or a reaction. So examples of chemical properties are toxicity, flammability, reactivity, which we're talking about today. So, some reactivity in terms of trends on the table, radioactivity, ability to oxidize, and these chemical properties, remember, are similar as they go down the groups or the columns. So, all the elements in group 1, the alkali metals, have similar chemical properties. All of the elements in group 2, the alkaline earth metals, have similar chemical properties. That's going to be the same for every group in the table. And remember, the groups are the columns, the families, they go up and down. So a periodic trend is just a pattern on the periodic table that demonstrates the different aspects of certain elements, like the size and the electronic properties, which we'll be talking about today. So first, let's talk about the atomic size, so the atomic radius, how large the atom is. The atomic radius of a chemical element is the measure of the size of the atom, so the distance from the nucleus to the outside of the electron cloud. So if you remember calculating the area and the circumference of circles in math class, similar thing. So it's just the distance from the nucleus to the outside of the electron cloud. Now it makes sense that if you have more energy rings, more energy levels, the radius of your atom is going to be larger, right? So as we add more of those energy rings, we're going to get a bigger atom because we have to fit more electrons in there. So as you go from left to right, the radius decreases. And then as you move across a period, the protons and their charge are stronger than the electrons' charge, pulling the electrons towards the nucleus, making the radius smaller. So, as we go from left to right, the atomic radii is going to decrease. So, from left to right, the radius is going to decrease. Now, as we go from top to bottom, the radii is going to increase. So, as you go down a group, each atom has another energy level, so the atoms get bigger. So, the radius will increase as you go down. So again, more shells, more electrons equals larger radius. So it decreases from left to right, increases from top to bottom. And that's just, again, the size of the atom. And this helps you, this will be a good little cheat sheet for us. It tells you what happens to the radius. So it decreases from left to right, increases from top to bottom. So questions for periodic trends could be like, okay, so which element has a smaller atomic radius, lithium or oxygen? Well, since we know that the atomic radius decreases from left to right, we would say oxygen, okay? And then we could do another question, which one has a larger atomic radius, lithium or potassium? Well, it would be potassium because it's further down on the table, and the atomic radius increases as we go from the top to the bottom. Okay, so as long as you can follow the trends and understand where the arrows are going, these trends are pretty easy to identify. And then of course, because your tests are open notes, as long as you understand how to read it, you'll be fine. Next is ionization energy, and that's the amount of energy required to completely remove an electron. So remember, our metals tend to donate electrons, and our nonmetals will take electrons. So removing one electron makes a cation, we know that, and the energy required to do this is called the first ionization energy. So ionization energy is how much energy it takes to remove an electron from an element. Now let's talk about what happens to ionization energy in the table. The first ionization energy decreases as you go down. Okay, this is because the electron is further away, thus there's more shielding by the core electrons from the pool of the positive nucleus. Okay, so electrons will shield the nucleus because the electrons are negatively charged, the protons are positively charged, and as you have energy levels that are further away, the shielding is not as intense, and so therefore it's easy to remove those electrons. So the energy decreases as you go down. So the further away you get from the nucleus, the easier it is to remove an electron. And all the atoms in the same period have the same energy level, but the nuclear charge increases as the number of protons increases. Therefore, ionization energy will increase from left to right. Okay? So as we move from left to right, ionization energy increases, so it's harder to remove an electron. And as we go from top to bottom, it decreases, so it's easier to remove as we go from the top to the bottom. Next up is electronegativity. So electronegativity is the tendency for an atom to attract a pair of electrons to itself. Large electronegativity means that the atom pulls the electrons towards it. So the more electronegative an element is, the more likely it is to take electrons and be able to take electrons from other elements. So it decreases down a group. So the further you go down, the more shells around the nucleus, right? We know because the more electrons there are, the more energy shells there are. This makes it harder for the positive protons to attract the electrons from the other atoms. So again, it's that shielding that happens in the nucleus that takes place where as those energy rings are further out, the electrons are further away. It's easier to remove the electrons, but then it's also harder for that atom to attract electrons to it. So it decreases down the group. And it increases as you go across a row. So the atomic radii decreases, and the smaller radii means a greater attraction for the nucleus to electrons. And this makes sense. So if we stop and pause, remember that our nonmetals on the right-hand side of the table are going to be those elements that gain electrons, right? So they take electrons or gain electrons from other elements that have less valence electrons. So it would make sense that as you go from left to right, those elements towards the right-hand side of the table are going to be more likely to take those electrons. So increases from left to right, decreases from top to bottom. Now let's talk about metal reactivity. So reactivity is just the ability to react with another substance, and reactivity for metals decreases as you go right across a period. And for metals, it increases down a group. Okay, so decreases from left to right, increases from top to bottom. Okay, so increases from top to bottom, decreases from left to right, which also makes sense because, again, these metals on the left-hand side, these are going to be the ones that have 1 or 2 valence electrons. They're looking to get rid of them, right? So they're more likely to interact with our super electronegative elements on the right-hand side. Okay, and of course, as we go from left to right, we're transitioning out of those metals into our nonmetals. And then reactivity for nonmetals increases as you go right across a period and decreases as you go down a group. So as you go from left to right, your reactivity for the nonmetals will increase and then decrease as you go down. And again, reactivity is just how likely is this element going to be to react with another element. And so nonmetallic character or nonmetals increases from left to right. Again, it makes sense. As we are moving through these nonmetals, especially in group 17 or 7A, the halogens. The halogens are very reactive because they only need one electron to fill their outer energy shell, and so it's very easy for them to take that electron, especially from an alkali metal. So these are going to be very reactive, okay, and it decreases from top to bottom. Just a reminder too, so we're all on the same page, your group 18 or 8A are your noble gases. They're stable. They're non-reactive. Noble gases are stable. Okay. Now, metallic character is how readily an atom can lose an electron. It decreases as you move right across a period and increases as it moves down. Okay, again, makes sense because we know that those metals on the left-hand side are easily ready to donate their valence electrons. And then as you move from left to right, as we move into that non-metal category, the metallic character is going to decrease. So from left to right, decreases. From top to bottom, increases. And remember too, as we get into these higher energy shells, these electrons, again, are further away from the nucleus, so they're not as protected as that attraction between the protons and the electrons. So the further they are away from the nucleus, the more likely it is that they're going to be donated, because it's easier. They have that super low ionization energy, so it's easy for them to get plucked off from their valence shell. Okay, and then there's just your summary. Now, with this periodic trends, again, you guys have access to the slides. You're going to put this information in your notes. You will be able to refer to your notes on your assessments. You just need to be able to, like with a question, be able to identify why the trends are what they are. And then if you have a question like, which one of these elements is more reactive or has more metallic character, you just have to be able to look at the trends from your notes and be able to tell, okay, this element is further right, therefore this one will be more whatever, okay? Also, too, it makes sense in terms of what we've been learning about energy shells and the electrons filling, valence electrons, how the metals will give up their electrons and the nonmetals will take the electrons. This is just kind of pulling it all together. Okay, so we want to make sure that we know the trends and can be able to differentiate between the trends when the time comes. Okay, and that's it. That is the end of Unit 1. If you have any questions, of course, let me know. You guys are going to be starting a study guide today. The first few questions have to do with periodic trends. And remember, your study guides, your warm-ups, and your exit tickets will always be a great place to start studying for a test. If you have any questions, let me know. And if not, I will see you guys in our next lesson. Bye, guys.